Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss the permutation and combination. So, what is the difference between permutation and combination? This is what we are going to know now. So, we'll start with the definition of permutation. Definition of permutation is the possible number of ways to arrange n number of objects. Okay, if the object order in the new arrangement matter. What does it mean? For example, I have numbers 1, 2, 3, and 4. In how many arrangements I can put them? I can put in many arrangements. I'll give you just an example. 1, 2, 3, 4. Could be 1, 3, 2, 4. 1, 4, 2, 3, 2, 3, 3, 2, 1, 4, and so on. Many arrangement. Does the order matter? It depends. It depends. So, for example, if I want to use these numbers as a key locker, here, as you can see here, if we change this order, does the locker will open? No, it will not open. So, in this case, the order matters. For example, here I start with the color black, then red, then yellow. It differs from if I start with the black, then yellow, then red. It differs from start with red, then black, then yellow, and so on. Okay? So, in these cases where the order matters, it is permutation. But, for example, if I told you that, okay, I have this bonbons, the sweets here, and I'll give you one here. Does it matter if you take the first line? I give you one line. Does or second line or first line or fifth line? Second, any of these lines? No, it doesn't matter because at the end of the day, you will get one black bonbon, one red, and one yellow. Here also one black, one yellow, and one red, but the same three bonbon color. Maybe this is your favorite. Maybe this is your favorite. But at the end of the day, you will get the three colors here, the three colors here, the same three colors here. So the order, which one comes first here of this line, each line, it doesn't matter. It doesn't matter. So in this case, it will be combination. It will be combination. So if the order doesn't matter, it will be combination. If the order matters, it will be permutation. We'll come across these points in the next slides also, and it will be more clear to us. Okay. Okay. So here we only talk about the permutation and definition and the order matters, and also we talk about it very quickly about combination and the order doesn't matter. What does it mean? Doesn't matter. It doesn't matter means for us which arrangement will come. It will not make any difference for us. Which item will come first, it will not affect us. In this case, it will be combination. But if it differs, the difference is matter for us. If the order matters for us, so it is permutation. So just let us put it in a different way. I'll give you an example and then we'll come in touch with many other examples in detail and with some calculations as well. If I have a committee of three members, one of them is the president of the committee, one is vice president, and one is the secretary of this committee. And I have to select them from 10 shareholders. So I have the 10 shareholders. I select the first one will be the president, second one will be the vice president, third one will be the secretary of the committee. Here is the order of the selection matters or no? Does this order matter? Yes, it does matter because the first one will be different than the second one, will be different than the third one. The first one will be selected, it will be the chairman of the committee. He will be in the best position. The second one will be only the vice president in a lesser position. The third one will be the secretary, which is the secretary of the committee, which will be the lower position among the three. So here the order matters. The order matters. So this is permutation. But if I have a team and I have one captain already selected, and I need to choose two co-captains. So I have a team and I need to select two co-captains. Does it matter which one will come first? I already selected two. Here, remember that I'm talking about the new arrangement. I'm not talking about the original objects which I have. I'm talking about the new arrangement, the order in the new arrangement. The order of the two co-captains which I have, not the order of the 11 players which I have in the team. No, I'm talking about the order of the new arrangement. The order of the new arrangement. So does it matter if you select as the first co-captain or the second co-captain? No, it doesn't matter. At the end of the day, you will be called co-captain and this one will be called co-captain. It doesn't matter. So it is combination. Just to make it more simpler, let us talk about here. This is combination. For example, here I have three dresses. One of them is red, one is blue, and one is green. Does it matter if I buy the three color? Does it matter what is the order of them? Blue is first, or red is second, or red is first, or green is first, or green is second, or green is last. It doesn't matter. At the end of the day, I'll buy these three dresses. So if the order doesn't matter, it is combination. And I'll have only this arrangement because I can switch between them. I can swap the green in the place of the red in the same place of the green, the blue in the place of the green in the place of the red, or the place of the blue. It doesn't matter. So it would be one arrangement only because the order between these elements or this object doesn't matter. But if it is permutation here, it will matter. Okay, so I have many arrangements. This arrangement differs from this arrangement, differs from this arrangement, differs. So I have here many arrangements. Okay, so the green will appear first here twice, then green twice, then blue twice. Okay, and this so on. So if we talk about the second also, blue appears second here and the blue appears second here. Green appears second here and second here. So I have these six arrangements covers all the options which are available to me for the new arrangements. So in case of the permutation, I want to a rearrangement in the permutation. Okay, I have many options, but if it is combination, because the order doesn't matter, it will be only one combination. Okay, so let us talk here about these three aliens which we have. Okay, we have one yellow, one red, and one blue color. If I want only to pick two of them, I can pick the yellow and the blue, yellow and the red, and then lastly the red and the blue. This is combination. Why? Because the order doesn't matter. How the order doesn't matter? Because I have more options which I can select also between. I can take this blue first and the yellow second. So if this matters, I'll have two options here. I'll have yellow and blue and yellow. But in this case, if you can see here, I have only yellow and blue because it doesn't matter. So this is combination problem. Okay. The same thing here. I have yellow and red. If I have red and yellow, so this is permutation. If I have only one of them, this means the order doesn't matter. So it is combination. I hope this make it clear a little bit, and it will be more clear in the next slide. Okay, so coming back also here to the difference between the permutation, the combination, and we have already given this definition here and definition here. Here the order doesn't matter, okay, and here the order matters, okay. Let us give an example. I have three letters A, N, T, the word and I want to put them in different arrangements. So I can put A letter first or A letter first here. If I put A letter first here, I can put the second letter N, so the third will be T. If I put the first letter A here, which doesn't differ from here to here, and second T and third is N, so I'll have different arrangements. So A and T, here A, T, N. Both are not the same. For example, assume this is a locker pin, which will open the locker. If you put in this order, it will open. If you put in this order, it will not open. See, so here, the order matters. The order here matters. So this is permutation case. Also, we can start with N. So N, A, T, A, T. Then N, T, A. Then we can start with the T, T, and T with two options, other options, TAN and TNA. So I have six orders here. Okay. If I look at this one, so when I come to select the first letter here, how many options are available to me? I have the three options. I can put A, I can put N, I can put T. So the first available number of ways is three. For the first letter, I have three ways. I can put it A, I can put it N, I can put it T. For the second letter, I will be having only two. So for example, I selected here A, I end up with N and T only. Okay. For the third one, I have only one option. If I put N here, so I end up with T. So the number of ways to form or to arrange these are as follows. So for the first letter, I have three options. The second, I will end up with only two because I will use one of these three here. One of the three letters, I will use one of them here. So I will end up with two only available for the second letter and one for the third. So here it will be 3 times 2 times 1 equals 3 times 2 equals 6 times 1 equals 6. So how many options we have here? Six options. Okay? But if we look at this 3 times 2 times 1, we remember one thing which we have taken earlier in grade 11 in the secondary school or grade 12 was factorials. You remember factorials? Yes, I remember factorials. It was written always, they used to write it in two different ways. For example, 5 factorial used as 5 times 4 times 3 times 2 times 1. Sometimes they type it 5 factorial 1 starts with 1 times 2 times 3 times 4 times 5 until they reach 5 and or start from 5 until they reach 1. Anyway, both are the same, will give the same result. Okay. So here it is clear for us now that the number of ways or the number of options would be three. For the first letter, we have three ways to put it. Times. For the second letter, we have two ways. For the third letter, we have one. So we'll have six ways. Okay. These are the six ways. For combination, it doesn't matter. It could be A and T the same arrangement, A and T or ATN or NT or NTA or TN or TNA. But at the end of the day, all of them are the same thing because it doesn't matter what is the order of the letters. NT in this case is same as ATN, the same. At the end of the day, in my bucket or in my plastic bag, I'll put this three letter A N T. Here also I find A N T. So if I get a plastic bag like this, okay, I'll find here A N T. It doesn't matter who comes first or who comes last, okay? But if it is a locker, it matters. A T N, for example, this is the key. It's different from another option, okay? So here it is permutation if the order matters. It is combination if the order doesn't matter. Okay, I hope this is clear. We'll start giving some more explanation with some examples also on both permutation and combination. Some examples on permutation in a company. You want to select a president, vice president, and general manager for managing board of this company. You have a managing board who's ruling the company, who's managing the company, and it has three members. This board, the president, vice president, and general manager. Okay, and you want to select them. Are they equal? Does it matter if you select the first one as president, second one as vice president, or third one as general? Anyone will become angry. There's a difference. Anyone will be running to be selected the first. Yes, it is. Everyone will be looking for the president position. Will be looking for the president position. Okay. Secondly, will be vice president, and lastly will be the general manager. Okay. So the order here does matter. It does matter. So it is permutation problem. Okay. So the question here, does it matter who among people you selected will be the president? Yes, it is. And who will be vice president? Yes, it is. And who will be chair? Yes, it is. Yes, it is matter. The first selected person will be the president and will have the better chance over the others to rule this big position in the company. And the second selected person will be in a lesser position, and the third selected will be more lesser position. So the lucky one will be selected for the president position, and the less lucky was for vice president, and the least likely person would be general manager. Okay, so it is a clear permutation problem. But if we took another example, and this example is not permutation, if we took another example of combination. So here, in your street, you want to select five people and give each of them $5 from the street. So every one of the selected team will be getting $5. Does it matter who will get first? As far as any of them will get $5, it doesn't matter. At the end of the day, once he selected the new alien, he will get the five. If he selected first or second or third, as far as he is one of the five people, for the selected people, the five selected, it doesn't matter who comes first. Every one of them will take the $5. Okay? So in this case, the order doesn't matter. So it is a combination problem. Okay? Okay. So in the previous pages, we said, okay, we have, for example, three people and they'll select three. We have four people and they'll select four. We have five people and they'll select five, but in different arrangements. So, for example, I have three colors. I select the green first, or the red first, or the blue first. I have five people who will come first, and each one of them will take $5. So it matter or doesn't matter. But in some cases, you have a big group of people, which we can call them n equals, for example, 10, and I want to select only three. We can call this is K. This is the sample which I will select. So I have total 10 and I will select three. This will make it different for the number of ways to arrange this small group of people, or it will be same as if we are rearranging 10 people. So just to make it clear, the first examples which we have taken, we have 10 people and we want to arrange them in different groups of 10 or three colors, and you want to arrange them in three color different arrangement: red, green, yellow, or yellow, green, red, and so on. So we are using the same three. We are using the same 10. But in some other cases, we have 10 and we want to select only three out of 10. So we are not using all of them. Does it matter in the permutation or in the combination? Yes, it matters. So here we'll have different way of treating or dealing with this example. Okay. In the examples given previous slides, we have used all the objects, but in reality, in most of the cases, we are picking. Okay, yes, we are picking and using part of the given object. Okay. For example, implementation, football team. Okay, captain and the captain assistant. This is permutation or yes, because the first one which will select it is the captain and the second one will be captain assistant. So both are not the same, so it is a permutation because the order matters here. Sitting around a rectangular table, who will sit first? Who will sit second? Who will sit fourth? If I have a plate here, for example, and so it matters who's sitting first, who's sitting second. But if it is a circular table and the plate is here, it doesn't matter who's sitting where because all of them will have access to this. There is no order here, okay? So if some people will sit around the rectangular table, so it matters who sits first, who sits second, who sits third, fourth, and so on. If the people will sit around circular table, it doesn't matter because there's no difference. Don't sit here, or don't who will sit here, don't who will sit here, don't who will sit here, here. There is no difference. There is no start. At the end of the day, it is a circle. Okay? Circle doesn't have a start or end. But the table, rectangular table, it it has a start and it has end. Okay? It has a start and it has end. We'll go back up to here. Okay? Okay. So examples of permutation, the football team, if you will select captain or captain assistant. If you will select co-captain, it doesn't matter. Sitting around the rectangular table, it is permutation also. In the above example, the order of the arrangement matters. If we look at the combinations examples, sorry for that, combination, if we have a swimming team and we want to select the members of the team, only members, there is no captain whatsoever, but the members, it doesn't matter. Swimmer 1, swimmer 2, swimmer 3, swimmer 4, all of them will be swimmers in the same position, so it doesn't matter. We're not talking about captain or coach or captain assistant. All of them are members. Also, if we are sitting around circular table, it doesn't matter. Okay, okay. So here we talk about how to arrange the letters A and T in one of the previous examples. So we said that the first letter will have three chances. The second letter will have two chances. The third letter will have one chance. So we can say the first letter three chances. The second letter we have two chances. The third letter we have one chance. Okay. So total chances will be six chances. Okay. So it will be 3 times 2 times 1. If we recall this from the factorial topic, this was called 3 factorial, which equals 6. Okay, so here I think it's better for us, or we need to refresh our minds and our memories about the factorial. If you remember, the factorial of 6 starts with 6. As I told you, some people are writing it other way around. They're writing it 1 times 2 times 3 times 4 times 5 times 6. Starting from 1 up to the factorial number. Factorial of 5, 1 times 2 times 3 times 4 times 5. It doesn't matter as far as you start from 1 to 5 or 5 to 1, but all of them are multiplied with each other. So 5 started from 1 to 5, 6 started from 1, and then double 6. So this is the factorial. And for the 4, it is the same thing. 4 start with 4 and end up with 1. 3 start with 3 and end up with 1. 2 start with 2 and end up with 1. 1 is only 1. The three important things which also you have to keep in your mind, the factorial of 0 is 1. So factorial of 1 is 1. Factorial of 0 is also 1. Okay? There is no factorial for negative numbers. So any factorial of negative number is infinity. It will give you an error. You cannot use it. There is no also factorial for fractions. So if you have a fraction, there is no factorial for the fraction. It will be infinity also. So I want you to keep this 3 in your mind. Factorial of 0 is 1. Factorial of negative is infinity or error. Factorial of 1/5 is infinity as well. Okay? Okay. So in continuation to our review of the factorial, because some of you already did not study factorial in depth during the secondary school level, or some of you already forget it and just need some refreshment. So when we have factorial of 7, we can prolong it and make 7 times 6 times 5 times 4 times 3 times 2 up to 1. Anything up to 1. Factorial of 5 equals 5 times 4 times 3 times 2 times 1. So we can cancel 1 with 1, 2 with 2, 3 with 3, 4 with 4, 5 with 4. We end up with 7 times 6. And the rest would cancel each other. Okay? So before doing this, we can make it in a simpler way. Instead of canceling each other, we can say, okay, this is 5 factorial, and the up to here, it is 5 factorial. So we can say 7 times 6 times 5 factorial, because 5 factorial is not 5. 5 factorial is 5 times 4 times 3 times 2 times 1. So 7 times 6 times 6 times 5 factorial, which is here. And here, this is 5 factorial. So 5 factorial will cancel with 5 factorial, will end up with 7 times 6 equal 42. Okay? I hope it's clear. So just as a repetition, the same example, 7 factorial times 6 factorial. So it will be 7 times 6 times 5 times 4 times 3 times 2 times 1. And here 6 times 5 times 4 times 3 times 2 times 1. Okay? So all these from 1 to 6 will cancel each other up to from 1 to 6, and we'll end up with 7 only, which is this answer. But instead of going every time in this detail, just will expand 7 factorial 2 times. It will be 7 factorial times 6 factorial, because at the denominator, it is 6 factorial. So we need to have the same factorial in the numerator up here. Okay? So we just expanded one more, so 7 times, but this is 7. Keep in mind it's not 7 factorial, it is 7 only. And the last one is 6 factorial. Okay, so here it will be 7 times all this, which is 6 factorial. Keep in mind that 6 factorial is not 6, it's 6 factorial. Okay, so 7 times 6 factorial. And here is 6 factorial, so it will cancel each other. So from now on, no need to have this step because we are big enough to understand now how to answer such problem. So if we say 6 factorial divided 4 factorial, no need to expand it fully. So 6 times 5 times 4 factorial. Because times 4 times 3 times 2 and so on. Okay? For here it will be 4 factorial. So we can cancel 4 factorial with 4 factorial and then that was 6 times 5. I hope it is clear. So here, like the same example here, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, I don't need all this. I need up to 6 factorial. So here 6 factorial is same one. So I'll cancel this one with this one. So okay. I keep in my mind that I need 7 times 6 factorial divided 6 factorial. 6 factorial divided 3 factorial. So I'll expand it 6 times 5 times 4 up to 3 factorial. And we have 3 factorial cancel each other. So we'll end up with 6 times 5 times 4 equal 120. Okay, sometimes come a little trickier and said, okay, n minus 1 factorial divided n minus 2 factorial. If you remember, when we have 7 factorial, we have 7 times, we reduce 1, 6 times, reduce another 1, reduce another 1, reduce, and so on, up to 1. Okay, up to 1. Let us write it in a nicer way. Okay. So every time we are reducing 1, reducing 1 more 1, but 5, 1 more 4, reduce another 1, 3, reduce another 1, 2, reduce another 1, 1. So every time we are reducing 1. So when I have this 7 factorial, I key expanded and 6 factorial, it is 6 times 5 times 4 times 3 times 2 times 1. Every time also I'm reducing 1, 1, 1, 1, 1, and it will cancel each other. So I want to reach 7 times 6 factorial, and here 6 factorial, so it will cancel each other. Okay, so here, if I want to expand it, so which one I'm expanding? Expanding the denominator or the numerator itself? I'm expanding the numerator because this is the bigger figure. The bigger is the 7 factorial, not 6 factorial. So I have to expand the biggest one until I go down until I reach the start of it, which is 6 factorial. Until I reach 4 factorial. Until I reach 3 factorial, and so on. So here, if I want to expand this one, which one I have to, I don't have numbers here, which one I have to expand? Shall I expand n minus 2 factorial or n minus 1? If you have 7 minus 1 and 7 minus 2, which one is bigger? 7 minus 2 is 5. 7 minus 1 is 6. So 6 is bigger than 1. So if the minus is lesser number, it will give us bigger. So minus 1 gives us 6. Minus 2 gives us only 5. Okay? So I have to expand this one. So this one, it will be n minus 1. In the same way we had here the 7. We put it n minus 1 times, we have to reduce 1 n minus 2. The same way with times 6. Right? N minus 3 and so on. until we reach n minus 2. Oh, but we have already reached n minus 2 here. So, okay. So we have to stop here, and this will be the factorial, and here n minus 2 factorial. If it is n minus 3, I have to expand one more. If it was n minus 3, I have to expand one more here until the end reach n minus 3. But since it is n minus 2, I have to stop here. So in this case, what will happen? N minus 2 factorial will cancel n minus 2, and you end up with n minus 1. Let us look at the example I have solved here with you for you. So I have here n minus 1 factorial divided n minus 2 factorial, the whole bracket factorial. It is not 2 factorial. It is n minus 2 fully inside the bracket factorial, n minus 1 factorial. So I have, which one is the bigger? N minus 1 or n minus 2? Of course, n minus 1 is bigger than n minus 2. So I have to expand this one, n minus 1, until I reach here, n minus 2. And immediately I reach n minus 2. So it is n minus 2 factorial. This one will cancel this one, so we'll end up with n minus 1. Okay. So let us take another example. N minus 1 factorial divided n minus 3 factorial. So I have to keep expanding, reduce every time 1, reduce 1 every time until I reach n minus 3. So n minus 1 times n minus 2 times n minus 3 factorial divided n minus 3, and this will cancel this. So we'll have n1 minus n2. I can even expand it, n squared plus 2 minus 3n. Okay. If I have only n and here n minus 2, the same thing every time, I'll start with n, because n is bigger than n minus 2. N is bigger than n minus 2. And expanded n times a minus 1, reduce 1, times a minus 2, until I reach here, n minus 2 is okay. So I have to stop here. So cancel this one with this one. We end up with n times n minus 1 equals n squared minus n. Okay, so here we'll start some real examples on the permutation and how to answer them.